Most people watching the economic fight between Washington and Ottawa are focused on the visible battles: lumber, steel, dairy, auto manufacturing, tariffs that dominate television panels for a week and disappear the next. But almost nobody is paying attention to the single resource quietly shaping the future balance of power between the United States and Canada. It is not oil. It is not natural gas. It is not lithium. It is uranium. And not just any uranium. The specific high-grade uranium buried deep beneath northern Saskatchewan that now sits at the center of the American nuclear future. For years, uranium was treated like a background commodity, necessary but forgettable. A fuel source sitting quietly behind the electrical grid while politicians argued about more visible industries. That era is ending. The reality now is that nuclear power has re-entered the center of global industrial strategy at exactly the same moment the West is trying to sever itself from Russian fuel dependence. And once you understand how tight the uranium market actually is, the entire Canada-United States relationship starts looking very different. Because the uncomfortable truth is this: America cannot rapidly expand nuclear power without Canada. Not politically, not economically, not operationally. And the deeper Washington pushes into the next generation of nuclear infrastructure, the more dependent it becomes on a supply chain sitting largely outside its control. That dependency is no longer theoretical. It is already built into the structure of the North American energy system. Nearly a quarter of the uranium consumed by the United States commercial reactor fleet originates from one region in Canada. The concentration is extraordinary. Two mines, one basin, one strategic supply chain feeding dozens of reactors across the American grid. Those reactors are not small assets. They power entire metropolitan regions. They stabilize electrical demand during extreme weather. They support defense infrastructure. Increasingly, they are being tied to the enormous energy requirements of artificial intelligence and hyperscale data centers. Microsoft, Amazon, Google, Meta. The biggest technology companies in the world are all searching for stable, long-term electricity sources capable of supporting AI expansion. Nuclear energy has suddenly become attractive again because solar and wind alone cannot guarantee constant industrial-scale baseload power. That changes the importance of uranium overnight. And while the political class spent years arguing about pipelines and electric vehicles, the uranium market quietly transformed into one of the most strategically constrained commodity markets on Earth. The center of that transformation is Saskatchewan. Buried beneath the Athabasca Basin are some of the richest uranium deposits ever discovered. Ore grades there are not marginally better than global averages. In some zones, they are dozens of times richer than what many competitors can economically extract elsewhere. That geological reality matters because uranium mining is not something countries can scale instantly. New mines require years of environmental review, infrastructure construction, financing, regulatory approval, and technical development. In many cases, the timeline stretches beyond a decade. So when governments suddenly announce massive nuclear expansion plans, the fuel cannot simply appear because politicians demand it. And that is exactly where the contradiction begins. Washington wants a major nuclear revival. At the same time, Washington wants aggressive economic leverage against trading partners. Those two goals start colliding the moment uranium enters the discussion. After the United States moved to cut dependence on Russian nuclear fuel, utilities across the country were forced into a difficult calculation. Reactors already operating could not simply pause consumption. Fuel contracts had to be replaced. Alternative supply chains had to be secured. And once buyers looked across the global market, they found very few politically reliable suppliers capable of delivering the necessary scale. Kazakhstan remains a giant producer, but its logistical and processing relationships intersect heavily with Russian infrastructure. That creates strategic risk. Australia has significant reserves, but development timelines and export structures remain limited relative to rapidly accelerating demand. African production carries political and infrastructure uncertainty in several regions, which leaves Canada, not as one supplier among many, as the cornerstone. That distinction changes everything, because once a commodity shifts from replaceable to structurally necessary, the balance of leverage changes with it. Now layer another reality on top of this. The United States is not merely trying to maintain its existing nuclear fleet, it is attempting to expand it. Advanced reactor projects are moving through planning stages. Existing plants are extending operational lifetimes. New industrial policy increasingly treats nuclear energy as essential to grid stability, manufacturing growth, and AI infrastructure. Every additional reactor means additional long term fuel demand. And the market already looks tight. That is why executives across the nuclear sector have spent the last several years warning about an approaching supply imbalance. Demand growth is accelerating globally at the same moment supply growth remains constrained by long development cycles. China is building reactors at a pace unmatched by most Western countries. European governments that once planned nuclear phase-outs are reconsidering those decisions. Japan continues restoring portions of its reactor fleet. Middle Eastern states are entering the nuclear market for the first time. Eastern European countries are actively reducing dependence on Russian nuclear systems and fuel arrangements. All of them are competing for uranium. All of them prefer politically stable suppliers. And all of them are now looking at the same finite production base. This is why the Canada story matters far more than most headlines suggest. Because Ottawa does not need dramatic speeches to gain leverage in this environment. It does not need public threats. The strategic advantage already exists inside the market structure itself. The United States cannot easily pressure the Canadian uranium sector without pressuring its own nuclear future. That reality is becoming increasingly visible through corporate partnerships. One of the most important developments in recent years has been the growing alignment between Canadian uranium production and American reactor expansion strategy. Canadian-controlled interests tied to reactor technology, fuel supply, and long-term deployment are becoming embedded inside broader North American energy planning, which creates a strange political contradiction. Public rhetoric may describe economic confrontation. Operational reality increasingly looks like interdependence. The louder the political theater becomes, the more obvious the structural dependency underneath it appears. And energy markets do not care about political messaging, they care about physical supply. That is why production decisions in Saskatchewan now carry enormous international consequences. Even modest output adjustments can ripple through global pricing expectations because utilities understand how limited replacement options truly are. Long-term fuel contracting has become increasingly competitive. Buyers are attempting to secure future supply years in advance because nobody wants to discover too late that available material has already been committed elsewhere. This is particularly important for the United States because nuclear reactors are not optional infrastructure once they are operating. Utilities cannot simply improvise fuel systems on short notice. The entire industry depends on stable procurement planning stretching years into the future. And the future now looks crowded. Artificial intelligence may intensify the situation even further. The electricity demand projections attached to advanced AI systems are staggering. Hyperscale data centers require immense continuous power consumption. Technology firms are beginning to evaluate dedicated nuclear partnerships because intermittent energy sources alone cannot reliably support future computational growth. That means the uranium market is no longer only about national grids. It is becoming connected to the future architecture of digital infrastructure itself. The fuel sitting beneath Saskatchewan increasingly touches everything: electricity reliability, AI expansion, industrial reshoring, grid modernization, strategic competition with China, decoupling from Russia, even military resilience. And all of this is happening while the public conversation remains focused on tariffs and trade headlines. Now consider the political implications. If Washington escalates trade pressure broadly against Canada while simultaneously depending on Canadian uranium to support nuclear expansion, eventually those strategies collide. At some point, policymakers are forced to acknowledge that certain commodities cannot be treated like ordinary imports. Potash already demonstrated part of this dynamic in agriculture. Uranium may demonstrate it even more dramatically in energy, because the operational consequences arrive quickly. If fuel markets tighten too aggressively, utilities face higher contracting costs. Those costs eventually flow into electricity systems. Higher electricity costs affect manufacturers, industrial operators, data centers, and consumers. In other words, the economic effects spread far beyond the nuclear sector itself. That is why energy analysts increasingly view uranium through the lens of strategic security rather than simple commodity trading. And Canada understands this quietly, carefully, without needing to say very much publicly. The advantage of geological leverage is that it rarely requires dramatic confrontation. The leverage exists whether politicians discuss it or not. A mine either exists or it does not. A deposit either contains high grade reserves or it does not. A supply chain either has replacement capacity or it does not. Those realities cannot be negotiated away through rhetoric. Which brings us to the next phase of this story. Over the next several years, the United States will move deeper into long term nuclear planning. Utilities will continue negotiating future contracts. Reactor developers will seek financing certainty. Technology companies pursuing massive AI growth will demand stable electricity guarantees. Governments will continue framing nuclear power as part of energy security strategy. At the exact same time, competition for reliable uranium supply is likely to intensify globally. That combination creates three possible outcomes. The first is managed accommodation. Under this path, Washington quietly recognizes the strategic importance of Canadian uranium and treats it differently from other politically contested sectors. Public disputes continue elsewhere, but nuclear fuel supply remains insulated from major escalation. Existing partnerships deepen. Utilities continue long-term procurement without major disruption. The market stabilizes around the assumption that Canadian uranium is effectively indispensable to North American nuclear strategy. This is the most economically rational outcome. But political systems do not always choose the most rational outcome. The second possibility is prolonged ambiguity. In this scenario, political tensions remain loud while the uranium relationship continues functioning underneath the surface. Governments avoid direct confrontation on nuclear fuel because the operational risks are too high, yet they also avoid openly acknowledging the dependency. The result is a strange dual reality. Public rhetoric signals confrontation. Actual industrial policy signals cooperation. This may ultimately become the most likely path because it allows both governments to preserve political messaging while avoiding serious energy disruption. But there is also a third scenario: escalation. If critical minerals become central targets inside broader trade disputes, uranium could eventually enter the political battlefield directly. And if that happens, the reaction from the nuclear industry would likely be immediate. Utilities would object aggressively. Industrial electricity consumers would object aggressively. States dependent on nuclear generation would object aggressively. Technology companies planning AI infrastructure around stable nuclear baseload power would object aggressively. Because unlike many trade disputes, this one intersects directly with long-term energy reliability. That is the key difference. The consequences are not abstract. They touch the electrical grid itself. And once policymakers confront that reality, the underlying imbalance becomes difficult to ignore. Canada possesses something the United States currently cannot rapidly replace. Not eventually. Now. That timing matters. New uranium projects elsewhere may emerge over the next decade. Additional enrichment infrastructure may be developed. Alternative supply arrangements may gradually expand. But none of that changes the immediate structural position. Right now, the North American nuclear future still runs heavily through Saskatchewan. That reality gives Ottawa a form of leverage very different from conventional trade power. It is not based primarily on threats. It is based on indispensability. And indispensability is often more powerful because it does not require constant demonstration. Everybody involved already understands the constraints. That is why some of the most important geopolitical shifts happen quietly. No dramatic summit, no explosive headline, no televised confrontation, just contracts being signed, supply agreements extending, utilities locking in future deliveries, governments adjusting strategy around realities they cannot easily change. Meanwhile, the broader energy transition keeps accelerating. Electric vehicles increase grid demand. Industrial electrification increases grid demand. AI infrastructure increases grid demand. Manufacturing reshoring increases grid demand. Nations attempting to decarbonize while maintaining industrial output increasingly discover that reliable baseload electricity becomes extraordinarily valuable. Nuclear power re-enters the conversation every single time. And every conversation about nuclear power eventually leads back to fuel, which leads back to uranium, which increasingly leads back to Canada. This is why the next contracting cycle inside the nuclear industry matters so much. The agreements negotiated over the coming years may shape reactor economics well into the next decade. Utilities are watching global competition intensify in real time. China continues buying aggressively. European demand continues adjusting upward. Emerging nuclear states continue entering the market. Supply is finite, and high-grade supply is even more finite. That means pricing power gradually shifts toward the strongest producers, especially producers operating in politically stable jurisdictions. especially producers with established infrastructure, especially producers already deeply integrated into Western energy planning. Again, the story keeps circling back to the same place: Saskatchewan, the Athabasca Basin. The concentration of uranium supply that quietly became one of the most strategically important assets in the Western energy system. And here is the deeper irony. The push for American energy independence may actually deepen structural dependence on Canadian resources in the medium term, because replacing Russian nuclear fuel does not eliminate dependency altogether. It redistributes dependency. And at this moment, much of that dependency points north. That does not mean Canada controls the entire system. It does not mean Washington lacks alternatives forever. But it does mean the current balance of leverage is far more complicated than standard trade war narratives suggest. The operational reality underneath the politics tells a different story. A story about geology, about supply chains, about industrial planning, about the limits of political flexibility once physical infrastructure becomes dependent on specific resources. And most importantly, about time, because energy systems move slowly, reactors take years to build, fuel contracts span long horizons, mining projects require enormous development timelines, which means strategic dependencies formed today can shape political relationships for an entire generation. That is the real significance of the uranium question, not the headlines of this week, not the speeches, not the tariffs dominating cable television. The real significance is that the foundation of the next North American nuclear era may already be locked into a supply structure centered on Canadian uranium. And once those structures harden, reversing them becomes extremely difficult. That is why this story matters. Not because of rhetoric, because of infrastructure. Because infrastructure outlasts politics. And because somewhere beneath northern Saskatchewan sits a geological advantage formed hundreds of millions of years ago that suddenly finds itself connected to the future of American energy, artificial intelligence, industrial expansion, and geopolitical strategy all at the same time. The public conversation still has not fully caught up to that reality, but the market already has. And over the next several years, governments will likely discover that geology can quietly overpower politics in ways no speech can reverse.